Okay, so let's continue on with another example here. Let's use the substitution method to solve this system of equations. We've got 3x plus y is equal to 2 and 2x plus 3y is equal to 8. Now, the substitution method said that for us to solve it, what we want to do is we want to use this, we want to write one of the equations of the system in terms of either x or y. And we're going to pick the one that's really the easiest for us to solve, if there is an easy one to solve. And in this case, there is. If we look at that first equation, right, we see that it's easiest to isolate y in the first equation. Right? So let's do the algebra here first. So we're going to take 3x plus y is equal to 2. And to isolate y, we would be subtracting 3x from both sides algebraically. And so we're going to come up with an expression that says y is equal to 2 minus 3x, or we could say negative 3x plus 2. Both are equivalent. And now y is in terms of x. Y in terms of x, right? So this is what we wanted. All right, so that means that in our second equation, everywhere we saw y before, we're now going to replace it with our variable expression 2 minus 3x. So it's going to become like this. Let's take our second equation right here and rewrite it. All in terms of x. 2x plus 3 2x, let's check that out, plus 3 times, we said y is 2 minus 3x, so 2 minus 3x equals negative 8. All right, so now we have to do the algebra and solve for x. So we're going to get 2x plus, distribute the 3, so we're going to get 6 minus 9x is equal to negative 8. Doing some extra algebra right here, we're going to get 2x and negative 9x gives us negative 7x equal to negative 8. We want to get x by itself, so we should be subtracting 6 from both sides. Subtract 6, subtract 6. We're going to get negative 7x is equal to negative 14. And if we divide everything through by negative 7, so divide by negative 7 on the left, divide by negative 7 on the right, we get x is equal to, let's see, negative divided by negative is a positive. 14 divided by 7 is 2. All right. Now what we should do is that we should back substitute this into the original equation and see what happens. So we could use either one of the original two. So the next step is to back substitute. And back substitute means we take the value we just found and put it into one of the two original equations. Let's take that first one. It looks pretty easy. We take 3 times 2 plus y, and that should give us 2. Well, this is 6 plus 2 plus y is equal to 2. So subtracting 6 from both sides will give us y is equal to negative 4. And so our solution looks like it should be negative 4. So it looks like we've done pretty good here. 2, negative 4, right? How do you check? Well, if you recall, the way to check is just to substitute that into the original two equations. Right? If you take 3 times 2, that's not a very good 3, but bear with me, plus negative 4, you get 2, and this is 6 minus 4 equals 2, so yep, that's true. How about the next one? What if I took 2 times 2 plus 3 times negative 4, would I get negative 8? Well, the answer to that is 4 minus 12 does indeed give us negative 8, so that's also true, and so that works. Right? Nice thing about system of equations, you can always check your answer. Let's try one more. Let's try this one. Let's use a substitution method to solve this system of equations. This time we've got 3x minus y equals 8 and y equals 3x minus 2. Well, if you didn't already observe, y is already in terms of x in the second equation, so all we really have to do is just take our rewrite step immediately. So let's do that. Let's rewrite. Replace y in the first equation with the variable expression 3x minus 2. So we're going to get 3x minus the quantity 3x minus 2 should equal 8 if we've done everything right. Well, how do we handle this? Remember, we have to distribute the negative that's outside of the parentheses to both terms inside the parentheses. We come up with 3x minus 3x plus 2, giving us equal to 8. And if we subtract 3x minus 3x, we get 0 plus 2 equals 8. Uh-oh. Is that true? Well, the answer, of course, to that is no. That's not true. What conclusion should we reach? Well, if you've been observing, of course, and you haven't guessed, what we've actually got right here is a way of indicating to us that we have what is called a inconsistent solution, right? This pair of equations right here does not have a solution, right? If I were to go back over here and I were to take my equations and I were to graph these two, look at what happens. Parallel lines, right? So in this case, what we've actually verified for ourselves is that when you get a solution that is not a solution, in other words, an inconsistent value right here, we say that this is our inconsistent system. So our solution to this equation is to say that it is inconsistent. That is no solution. I'll do my best with writing that. No solution. All right, good luck on your homework assignments. We'll see you in class.